Okay, in this lecture we will see the IC technology. Okay, so first of all you have to understand the definition of IC technology. So can anybody tell me what do you mean by IC? What is IC? What is IC? It's a, I think slide is visible to everyone, isn't it? Just give me some answer. Somebody should answer me. Is that everybody getting the slide? Yes. Okay. I think voice is also that is audible to everyone. Okay. So IC technology. Just see. We have seen the IC actually. What is IC? IC, that is the long form, is integrated circuit. Okay, or also called as a chip. Okay, so that's correct. Now, what is IC technology? That means the technology or your particular technology that depends upon the number of, just a minute, people are admitting. Okay, so IC technology is nothing but actually the fabrication part of your ICs. Okay, fabrication part of your actually IC or called as a circuits. Okay, so long form of IC we have seen, that is integrated circuit, or this is also called as a chip. Okay, now what is IC technology? The IC technology is nothing but the manner in which a digital, that is called as a gate level implementation, is mapped onto an IC. Okay, so whatever the digital circuit we have drawn, for example, you have drawn any AND gate, okay, NOT gate, XOR, okay, or not. Now that you have drawn on your, that is you have drawn by using different gates. Now you have to, this is what theoretically, if you draw these circuits on your notebooks, now this is theoretical one only. Okay, now to check it practically, you have to implement that gate, okay, by using some technology. So that technology is called as IC technology. So that is what called as the manner in which a given digital circuit is implemented, okay, and is mapped onto the IC. So that technology is called as a integrated circuit technology. Okay, that means how you are going to map your circuit, okay, on the integrated part of your circuits. Okay, so IC technologies differ in their customization to design. Okay, so customization, last time I have told what do you mean by customization. Okay, custom means according to the specifications. So, okay, IC technologies differ, okay, according to their customizations. So I just appeal to all the students to mute their mic. Okay, so I'm getting the voice. Okay, so it's getting disturbed. Just check whose mic is on. So please mute your mic. There are 28 students. Please check your mic. Try to mute your mic. Okay. Okay. So just see, IC consists of numerous layers. Okay, IC consists of the numerous means multiple layers, perhaps 10 or more. Okay, so whatever the IC we have fabricated, we have just know that our IC is having a single layer. In third year you have seen in the workshop of PCB layout design. So we have fabricated a PCB. So there are only two parts. One is a copper side. Okay, so that is called as a one layer of your integrated circuits. Okay, but in practical there are multiple layers of your circuits. Okay, means you can design on multiple layers. So it is not only single layer. So it is said that IC technologies differ with respect to who builds each layer and when. Okay. So simple circuit is shown. Okay. That is one IC is shown, that is integrated circuit, and there are different packages of IC. If you observe your microcontroller 8051 that comes in the DIP package, that is dual inline package. Okay. However, your LPC 2148 will comes in that is called as in quad package. Okay. So there are different types packages of your IC. Next, now what is inside this IC? Okay, that is very important. So can anybody tell me what is inside the IC? What is inside the IC? Anybody? What do you think? Which components are included in the integrated circuits? Okay, because now you are going to study all these things in your subject. Yes, transistors. Okay. Rohit has given the answer that transistor. Kumbhar also has given the answer that is transistor. So now in the subject of VLSI, you are going to study all these fabrication level, fabrication layers. So whatever the diagram that is shown, okay, Rohit also has given that is logical gates. Okay, but basically which logical gates? That is nothing but the transistors. Okay. Now again, this is not a BJT or such a kind of transistor. Rather than this is called as a metal oxide, your MOS devices, metal oxide semiconductor devices. That is your MOS, or the best technology that is used is a CMOS. Okay, complementary metal oxide semiconductor. So by using that CMOS technology, see, why I'm telling this is very important. CMOS technology is used to fabricate your different components. Okay, so those are called as a transistor. That is MOS devices are called as transistors. So that is what's shown on the diagram. Okay, just see source, drain, you have gate, you have oxide, okay, and channel. So there are different layers basically on this particular substrate. Okay, so there is a silicon wafer. Basically this is silicon wafer which consists inside the IC. On this silicon layer you have to build your all the components. Okay, you have to design all the components, and for designing the components you have go through one software. Maybe in VLSI you will go through the that software, what is something microvent. Okay, on which you have to design your devices, whatever the gates you will design practically on those software, and after designing that you have to implement it on the actual wafer. Okay, that is silicon wafer, and whose dimension is in micron. Okay, 10 raised to -6, -12, -9, like this. Okay, so it's very, very small. You will get more exposure to this in VLSI, but that is what the role of VLSI. Okay, in designing the all these kinds of devices, or whatever the circuit you want to implement, you have to implement by using that particular technology, and that you have to design on the silicon wafer. Okay, and that silicon wafer contains inside this IC. Okay, so that is what the IC technology. So there are actually basically different layers. In this, the bottom layer forms the transistors. Okay, not only one layer, but there are multiple layers over there. The middle layer form logic components. The top layers connect these components with wires. Okay, so first layer is a bottom layer. Okay, which forms the transistors. Second layer called as a middle layer, which forms the logic components, and the top layer is used to connect these components with the wires. So it is not necessary only to build it. After building it, you should have to implement the logic. Okay, let I have the different devices, that is NOT gate, AND gate, and the OR gate. Okay, now this gates is in a first layer. In the second layer, I have to implement my particular logic. For example, addition. So I will take two inputs and I will use one OR gate. Okay, now in the third step, you have to actually connect your inputs to the your OR gate. Getting? So that is a routing of the wires. So that is done in the third layer. So these are the different layers that are present in your this particular silicon wafer. Okay. So there are three major IC technologies. Okay, three types of IC technologies. First technology is called as full custom. Okay, full custom or VLSI. Okay, so again remember what is full custom? Can anybody tell me? Full custom means again according to the specification. Okay, or called as a very large scale integration. That means it has integrated large number of components. Okay. Second type is called as a semi-custom, okay, or also called as a ASIC, that is application specific integrated circuits. Okay, also called as a gate array and standard cells. These are nothing but the gate array and standard cells. That means you have to use only the required number of components, okay, or the logic gates that are specific to your area of application. Okay, for example, it is used for embedded applications, okay, or it is used for digital signal processing applications. Okay, so that's why this is called as a semi-custom. Semi-custom means according to dimensions, okay, but or according to the specifications, but the specifications are constant to the related field of application. Example is either it is related to embedded applications or it is related to your digital signal processing application. Get it? So this is what the difference between the full custom and semi-custom. Okay, that means both are designed according to the specifications. Only the difference is first is fully custom. Okay, that means all the components or gates are included in this, and in the second one only the required number of components. Now in the third, called as a programmable logic devices. Okay, so this is what we are using. Okay, so these are the or this is the type of your FPGA or CPLA devices, called as a programmable logic devices. So we'll see one by one. I think up to this it is clear. What is IC technology? Okay, so you have to fabricate your functionality. Okay, and to fabricate your functionality, you have to use different logic gates. Okay, on the silicon wafers, and there are different layers of this. Okay, so we will go for the first layer, called as full custom or VLSI. Okay, so just see the definition. All layers are optimized for an embedded system's particular digital implementations. Okay, all layers are optimized for an embedded system's particular digital implementation. Okay, so that means all the layers are already prepared. Are you getting? So what are the different layers? Just I have explained. That is placing the components, that is placing the transistor. I have placed the transistors. I have sizing the transistor. That is called as a scaling the transistor. Sizing means scaling. Okay, I have to put in a particular area only. Okay, that is called as a sizing of the transistors. And then the third is routing the wires. Okay, so I have put the all the transistors over there, and I have sized all the transistor according to the space available. Okay, and very important last is a routing the wires so that I can implement my functionality. Okay, for example, summation or the multiplication. Now, what is the advantage of this kind of IC technology? Okay, so this technology gives you the excellent performance. Okay, small size and low power. Okay, why it will give excellent performance having a small size and low power? It's very simple, because we have designed the IC according to the specifications only. Okay, so we are very much clear what kind of specification we will require in my IC. Okay, so only those specification I have included in my IC. So that's why the size of my IC is small. Okay, and it consumes the low power and gives you excellent performance because of this. Okay, so everything is very clear. Now, what is the drawback of this IC technology? So first drawback is high NRE. Okay, high NRE means non-recurring engineering cost. That is the design cost. So it requires high design cost. Why it requires high design cost? It's very simple because you have to design according to the specifications, and to design any project you require at least 3 to 6 months. Okay, minimum I would say, or maybe more than 6 months also. Okay, that means the design cost is more because of specializations. You have to design your IC according to particular specifications only. That's why the NRE cost is high. Okay, and since the NRE cost is high, okay, because of long time to market. Okay, so engineers required long time to design this particular product, and hence to launch your product into the market, it requires a lot of time. So that's why it requires long time to market. Okay, so what is the disadvantage? If it takes more time to launch your product into the market, so there may be the possibility of revenue loss. Are you getting? Okay, so this time should be shorter so that you will get the maximum revenue from the market. Okay, first point is not that much of important because you can recover this design cost, okay, if you produce the more number of products. Okay, however, second design material is very important because it will gives you a lot of process. Okay, so this is all about full custom. I think you have got the idea. Full custom IC technology means the IC is fabricated according to the particular set of specifications only. Okay, and in this particular IC, all the work is already done. Okay, means all the layers are already fabricated. Are you getting? Okay, that is, I have designed my IC for particular application directly. Okay, no work is pending. Okay, so there are three particular steps that are followed. First is placing the transistors, sizing the transistors, and routing the wires. That means to implement a particular functionality. For example, that is the IC for the addition of 2 or 3 inputs. Okay, so in the particular that IC, all the layers, that is placing transistor there is fabricated, sizing transistor is also completed, and routing of the wires is also completed. That means your IC is completely prepared for the applications. Okay, you are not going to change that application. So that is what the full custom IC technology. Okay, and the benefits also we have seen because everything is specific. So you are getting a small size. Okay, there are 10 minutes remaining, so maybe after that you have to rejoin the sessions. Okay, benefits I have explained, and the drawbacks also I have explained. Okay, I think it is clear. Are you getting the things or not? Yes or no? Just type yes or no. Everybody, are you getting this full custom IC technology? Yes or no? I'm not getting any response, so whether I'm online or not. Are you getting this full custom or VLSI IC technology? Or should I repeat one more time? Rohit? Rohit Talekar. Priyanka Matsali. Okay. No. You have not got the idea. Okay. Anybody else? What about other people's? Are you getting this technology or not? Rohit got it. Okay. Other people's? So you should have some. Okay. Yes. Okay. For Matsali, I will repeat one more time. Let's see. What is IC technology? IC technology is nothing but the way of fabricating the IC. Okay. So what are the different ways to fabricate the IC? So it's very simple. It is according to the design. Okay. What kind of design the customer or client wants? So that decides the IC technology. Okay. Now I will give the a simple example. Just see. Uh, uh, there are some, just say, for kids there are some models. Okay, we will make some models. Okay, so if you go to the shop, you will purchase the blocks. Okay, and in that block you have the some picture, or the picture of that particular model, and by using that block you have make a model. Are you getting this? I will give the simplest example of this technology. Okay, just think about the model. Okay, you purchase the blocks, okay, from the kids shops, and kids will build the particular type of model by using the blocks. This is what the simplest application. Now consider the first case. In the first case, I have purchased that particular model directly. Okay, that means there is no need to build that particular model by using blocks. So if I purchase that model directly, now that is the case of your full custom IC technology. Okay, means already that particular functionality is implemented in that particular IC. Okay, so this is what the analogous example. Okay, I think this may be clear. Okay, no need to means the designer or whatever the user or the client is there is no need to no need to create the required kind of functionality. That functionality is already created inside the IC. Okay, which is analogous to the ready-made model. Okay, then second type of IC technology is a semi-custom. Okay, semi-custom means, let's see, semi-custom means, let again the example of model. Okay, that means rather than purchasing a ready-made model from the shop, now I will purchase a model whose 50% work is already given in the model, and remaining 50% work will be done by the user. Okay, are you getting? 50% of the work is already done. Okay, when you at the time of purchase itself. Okay, so that means the company who will made this particular type of model, they have made the model 50%. Okay, and remaining 50% is prepared or built by the user, that is kids. So this is called as a semi-custom. Semi-custom means, that is, in terms of this IC technology, that means some of the layers are already fabricated. Okay, some of the layers are already fabricated by the IC at the time of fabrication itself, and some of the layers are remaining to fabricate. Okay, and so the remaining layers are fabricated or designed by the user. So that is what called as a semi-custom. So just see, lower layers are, that is what shown, lower layers are fully or partially built. What are the lower layers? Okay, I have just explained what is a lower layer. That is placing transistors and sizing transistors is already done. Okay, in the semi-custom IC technology, while some of the work is remaining, that is the top layer is remaining. So what is the top layer? That is, designers are left with routing of wires and maybe placing some blocks. Are you getting? So in semi-custom IC technology, the most of the layers are already implemented in the IC itself, but some of the layers, or that is called as the top layer, which is nothing but the routing of wires and placing some blocks. So that work is remaining, or that work is kept for the user of that particular IC. Okay, so that is called as a semi-custom IC technology, which is very much analogous to the example that you have purchased the model, which is already 50% built by the company itself, and the remaining 50% work is done by the user of that particular model. Okay, while in the first case, full custom, the company will give you the complete ready-made model. Okay, that means user has no work. Okay, it has to directly use that model directly. Okay, so that is called as a full custom and semi-custom. Now what is the advantages if you use a semi-custom IC technology. So the first benefit of using the semi-custom technology is the good performance, again good size, less NRE cost than a full custom implementation. Okay, that is what's shown, perhaps 10K to 100K compared to here 300K. Okay, so if you use semi-custom IC technology, the NRE cost, that is design cost, decreases. Why NRE cost decreases? It's very simple, just see. Because in the first full custom IC technology, all the blocks are designed by the designer, okay, before launching your product into the market. Okay, that's why it requires a lot of time, and if it requires a lot of time, you have to pay for the design engineer. Okay, so that is what the problem with the full custom. That is, everything is done by the designer before putting your product into the market. Okay. However, in the semi-custom IC technology, we are not going to design all the layers. Okay. So if you are not going to design all the layers, that means you require the less time to launch your product in the market. Okay. Less time means you have to pay less to the designers. Okay. Why to pay less for designer? Because they are not going to design all the layers of your IC. They are just designing maybe 1, 2, or 3 layers of your IC, and remaining layers are designed by the user after the launching your product into the market. Okay, so this is what the advantage of using the semi-custom technology or semi-custom IC technology. Okay, and it will reduce the NRE cost. This is what the justification. Now, what is the drawback of this semi-custom IC technology? Okay, so the drawback is still it requires weeks to months to develop. Okay, that means let a full custom IC technology requires let 1 year. Okay, to design and launch your product into the market. Now the semi-custom IC technology requires let 6 months. Okay, because you cannot reduce that particular time. Okay, that is very much, because anyhow you have to design that particular layers. Okay, means at least some of the layers you have to design, so it requires again lot of time. But compared to full custom,